As Janet said, my name is Ryan Neal. I'm up in Benton County. I take care of more of the horticulture side of things there as the agent. And actually, I did get a degree in soil science. So what I'm going to do today is try to take the 4 years of coursework and consolidate that into a 1-hour presentation. And so I will do the best to make good transitions and get everything out there to you in a way that makes a lot of sense. So let's go. Soil science is going to be the name of this program here. My objectives here are 3 things. I want to talk about the composition of soil, so what soils are made out of, how they're formed, what they look like, different things of the composition. I want to talk about fertility, fertilizers, and amendments, so kind of best management practices there, and then testing and nutrient management. And so we'll talk about a little bit of your soil testing, which of course is a big program that Extension runs and takes a lot of soil samples and sends them to the state level and then gives you a report. So we'll talk about how to look at that report and kind of get the best information from that. Okay, so what are soils? If you have a clump of soil, if you're looking at it, actually only 45% of that is a solid matter, and then the rest of that would be 25% air, so pore spaces, depending again on what the soil is made of, how long it's decomposed, where it's coming from. These things will change, but basically half of it is your mineral particles, so the breaking down of rocks. Half of it, or a quarter of it's going to be air, quarter of it water, and then a very small sliver of it, 5%, will be your microorganisms, your worms, your centipedes, different things living in the soil and digesting it, your bacteria, your algae. 10% of it will be the roots, and then about 80% of that will be humus. And we'll talk a little bit more about what humus is later in the program. Okay, so why are soils important? As a soil scientist, this seems like a silly question, but of course it is an important question. A lot of people kind of wonder, what is the difference between soil and dirt? That's probably a question that I get more often than not whenever I talk about soils. The easiest way I like to put that is dirt is basically soil that is in the wrong place at the wrong time. And so if you're out in your garden and you're walking in the soil being something that is useful and important to human life, if you track that on your shoes and bring it inside, then all of a sudden, then it can be dirt. So if you're having to clean up after it, then a lot of times it's dirt. But what we're going to focus on is soil. And so for a soil scientist, we never want to call something in our garden or in our field or that we're using that is essential to human life dirt. So we want to refer to it always as soil. Of course, soil has cultural importance, importance throughout history. Many civilizations were brought up and then brought down because of their treatment of soils. Okay, so we've of course read a lot of Steinbeck novels that talk about the Great Depression and the Dust Bowl and things that happened as a result. So mismanagement of soils can lead to the demise of civilizations, and that's been documented throughout the history of the world. Many of the cultures have been brought down either because of their use of water or soils, or the combination of both in some cases. And so African deserts were formed because of soil mismanagement. Tropical rainforests now we know are being depleted at a rapid rate. And so what is that doing to civilization if those soils are being depleted? And then of course the Dust Bowl. Okay, soils do by definition have 5 important functions. Of course, we're going to talk mostly in Master Gardeners, the importance is its supporting of plants. What it does for plants is, of course, provide an anchor, but it also controls the water. So depending on what that soil is made out of and what the texture is, the water can be either held or not held as well. So soils provide an important function with water control. Also recycling of nutrients. And so as organic matter decomposes, as fertilizer is applied to the soil, depending again on what the structure is and what the texture, can hold nutrients better or worse. Habitat for life, and so again earthworms, but also things like bacteria and algae, rodents, any number of things. And so it is habitat. And then of course less important for this, but important for many other aspects, roads and buildings, it is an engineering medium. And so depending on we're building and what we're using the land for, that can be of significant importance. Okay, so how does soil form? And so this is a fascinating subject, and you can see a lot of different figures. I have at the bottom here that 100 years to form 1 inch of topsoil. That would certainly be on the short end of things I've heard and read, where it might take 1,000 years to form a centimeter of topsoil. And so just depending on what the climate is like, what the parent material is like, what is growing there, these things change. But if we're talking about basic elements, we're talking about a rock that is ultimately being decomposed by life or by wind, water, being eroded away and turned into silt, sand, or clay, and then plants growing on that, animals feeding on that. Just that whole process can take a tremendous amount of time. Again, it's all dependent on what that climate looks like, how much it's freezing and thawing throughout the year, what's growing there, what the parent material is. But we'll talk a little bit more about just a common situation, which would be something like this. So, as we look to faraway planets, one of the most important questions to ask is if there is water, and more importantly, if there's water, then there's most likely life. And so as the Earth formed, it was basically a rock. And so eventually that rock supported life, and that might have been in the form of lichens or algae or moss. That lichen, algae, or moss is able to take nutrients from the soil, and very slowly, and this is again over the course of hundreds, if not thousands of years, that lichen can eventually break down the rock, and over time you'll see it goes from rock, water, and wind. Freezing and thawing can help break down that rock and provide more surface area for then lichen, plants, moss, things like that to have access to the pore space in the water and begin to break down the minerals and the nutrients that are available in that parent material and that bedrock in this situation. Over time, again, this could be shorter or longer depending on where in the world this is. But we start to get larger plant life, larger forms of life. In this case, we have plants. Of course, those plants are going to grow and decompose. That slow decomposition goes from organic matter to humus, which is the more stable version of organic matter. And so you can see that start to lay there on the soil surface, and that starts to be decomposed by higher life forms like bacteria, but then earthworms and different things can start to take that organic matter down lower into the soil horizon and start to bring that organic matter, which brings the bedrock more to life as it has access to nutrients, is breaking down. And then over time, we have the formation of what's called horizons. So this top horizon changes into a lower B horizon, into the parent material. And so again, this happens over the course of many thousands of years. This can be sped up. We know about river plains, and whenever the river comes in and it floods, it can deposit silt and clay on the soil surface, and that can certainly speed up the process. Many of our great soils were formed from the formation of glaciers that moved in, and through that tremendous friction, it broke down this parent material and turned it into dust. And then as glacials receded, then it left all of that parent material behind, which was then topsoil. And so again, it can be speeded up depending on what the land is like and what sort of the parent material goes through. But over time, we do get the breakdown of these horizons. We get the organic matter, and we get higher plant life. Of course, animals would then go through there and speed up this process even more as they eat the plants and then leave droppings there behind, which then get broken down, and it supports an abundance of life. Okay, we spoke just briefly on what horizons are. So if you were to look at the soil profile, and there's actually classes, but also when in college I was on a soil judging team, which we got to go around the country and look at different soils. And so they essentially take a backhoe into the soil and expose that soil profile. And so this might be a common soil here in this area to the right that you see. And so you see the different profiles. We have a very dark horizon up here on top. And so that's where you see most of the roots are growing. Those roots, as the plant dies, decompose. That decomposition tends to be dark in color. Many of us have seen compost, things like that. As that mixes with the topsoil or the top horizon here tends to become darker and darker. And so it's drawn out for us here on this side of the slide, where we have the O horizon, which is loosely and partly decayed organic matter. And so as leaves fall onto the surface, before they have the ability to totally decompose, they leave a loose layer here. And so in many cases, this is only going to be a layer, maybe a centimeter or two thick, and it'll be loose. It's not readily growing plant material. As we get down below into the A horizon, that's where most of our roots are going to be found. That's where a lot of the active processes of the soil are taking place. That's where decomposition is happening. That's where most of the life is going to be. So really the action is in between the two O and A horizons. As we get down below that, we're getting into, again, more of the parent material. There's leaching that's happening there. So nutrients, as they get washed through the soil, depending on what the texture is, are going down and potentially being lost into the groundwater or through fractures in the soil and through the bedrock. And as we go through, we can see certainly color changes. Below that in the B horizon, we have accumulations of clay, iron, and aluminum from above. And then below that, C horizon is partly altered parent material. But again, we're getting more into the rock and the formation of soils to begin with. And so these are all horizons. It's not important to probably memorize horizons, but just know that throughout the country and throughout the world, all these horizons look differently, and it just depends on the recycling and cycling of nutrients and organic matter and plants that are taking place here on the surface of the Earth's crust. Okay, there are different soil classifications throughout Arkansas and the world. Many of your county agents or county offices will have a book that has all of the soil types in Arkansas. So if someone back in the day actually went through all over the entire land and mapped out the different soil types, you can see exactly the farm that you have. You can look it up in this book. You can see how it's classified. You can see what the parent material is. You can see the different horizons, and it'll all be listed out there. It'll also share with you what the important uses of the land are. So of course we know that if you're going to build a skyscraper, it's important to know what the parent material is and what the soil is made out of. If you're going to have a farm, it's important to know, how deep the soil is, how many rocks there are. All of our county books, which again, I've got a couple of them in my office. I'd be happy to loan people out if you wanted to look at it or wanted to dive deeper into this soil taxonomy subject. But just know that someone before us, generation before us, has taken all of the soils and classified them, and really with great detail told us exactly what the best uses are for the soil, historically what the soil has been used for, and just really mapped those out for us, which has been an incredible service. Okay, so we have soil physical properties. Of the three physical properties, they are soil structure. The structure provides, as we talked about, water movement, porosity, aeration, heat transfer. Another physical property is the soil color, which can indicate the presence of organic matter, as we talked about in that A horizon. The darker that horizon generally means the more organic matter that soil has. It's not always the case, but in many cases can be an indication. It can give us the drainage class. There are chemical reactions that take place in the soil, which leaves us oxidation states of iron and manganese. And then it also has to do with the climate and temperature regime. We also have soil texture influences. Texture does influence, and we'll talk in greater detail about the infiltration of water and nutrients, the storage of the water and the nutrients, the aeration, so how much air is getting in depending on what the texture is, the fertility, the plant available water, and the soil till. Okay, so we'll talk a little bit in greater detail in this next slide about what exactly is soil texture and the particle size. And so our texture is something like a sand, silt, or clay. If it's a combination of any one of those, then it can be referred to as a loam. And so what this indicates here in the slide is just the tremendous size of what sand is compared to clay. silt being the medium-sized particle here. So all these are referred to as particle sizes. And so, of course, if we were to plant a garden on the beach, we would know that it probably wouldn't hold a lot of water. It's probably not going to hold a lot of nutrients either. It doesn't have a lot of pore space in comparison to something like clay, which is less than 0.002 millimeters. And so something that you wouldn't even be able to see with the naked eye. You probably wouldn't even be able to feel clay with your fingers. You probably have to put it in your mouth to be able to feel a clay particle. And silt would, of course, be something right in the middle. You can start to feel silt with your fingers, but certainly wouldn't be able to see anything that small. And then sand, you can start to see with your naked eye. Okay, if you were to know your percentage of silt, sand, and clay, then you can look at a soil textural triangle. And somebody like me that likes to nerd out on soils, I might use a diagram like this to tell me what I would call my soil. Okay, and so if you were to look at this, it does take a while, but you can start to understand if I had 30% silt, even a small percentage of clay, and then some percentage of sand, it might fall into somewhere loamy, which again, loam is by definition a mixture of two soil particle sizes with just a small amount of clay. It is classified just as clay. It doesn't take much clay in order for any classification to be called some form of clay. So we can have sandy clay, silty clay loam, etc. It's not likely that you'll be able to know by looking at your soil what percentage sand, silt, and clay you do have. There is a trick I can show you here in a minute about figuring out that percentage. But if you do know, then this is a kind of fun soil textural triangle that you can look at to try to figure out what your soil would be classified as. And again, if it's classified as clay, it might be better suited for land use, or for engineering uses. If it's more of a loam, so a loam soil, sandy loam, silt loam, then it might be better suited for like truck patch gardening or gardening in general. As we get to a less percentage of clay, soil tends to be easier to work. So if you were bringing a tiller in there, you'll see that it dries out a lot better, has a lot more pore space, so it's good for plant roots to be able to expand. And so all clay is not always ideal for a garden type situation. One thing you can tell without knowing what your percentage of sand, silt, and clay is, you can try to figure out what your soil texture is by the ribboning method. Okay, so in this situation, if you were to take a handful of clay and you were to squeeze it, if it drips out water as you squeeze it, then it's most likely too wet. If it breaks apart, then it's most likely too dry. But if it holds together and breaks apart, if you work it a little bit, then it's a good moisture. If you're to take that soil at that moisture level and create what's called a ribbon, so you can see these pictures here where the fella is taking it in between his thumb and his forefinger, trying to mash out a ribbon. Okay, as he does that, if it falls directly onto the ground and doesn't make any length of ribbon, then it says here that it's mostly a loam of sand or silt. And so again, the larger the particle size is, the less likely the soil is going to be able to stick together. If we go into 2 to 5 centimeters of the length of that ribbon, then we know that it's mostly a loam, but it's teetering on the clay side. And then of course, if you're able to make a ribbon that's over 5 centimeters, which would be over 2 inches long, then you're dealing with mostly clay. And so this is a very practical thing. If I go out to somebody's farm and they're wondering why their soil is holding so much water, or why plants just aren't generally growing good, or is this a good location for a fruit tree, or just trees in general, it's important to dig a hole. I can take a handful of that clay and I can get a pretty good idea without any sort of hand lens or taking it to any sort of lab. I can get a pretty good idea of what that percentage of sand, silt, and clay is just by using this ribboning method. And so that's something that you can do at home. It's worth practicing. It's worth just going out in your garden right now. You could feel it and kind of get an idea of, do I have mostly clay? Do I have mostly silt, sand? maybe a percentage of each, just so you know sort of what the best uses of your soil are. These can of course be amended if you have a mostly clay soil, but that's the best place for a garden. You don't want to move, and there are things that you can do, and we'll talk about that a little bit later in order to try to make that garden more suitable for growing plants. There is a slightly longer, but certainly a household way of telling if you have a percentage of sand, silt, and clay, and that is, I just call it the jar method. And so if I was to take a quart jar and put between a cup and maybe a pint of soil into that jar, and so that would be your topsoil, probably your top 6 to 4 inches. Just like I was taking a soil sample, if I was to take a handful of that soil and put it in a jar, a lot of times it's important to try to break it up as much as possible. If you can get the grass or the organic matter that's just sitting on top of the soil out of there, break it up as much as possible. But anyway, put it in water, put it in a jar with the lid secured, shake it really good so all the particles are broken up and you don't have any big clods. If you were to let that sit, and it might take up to a week, then you'll start to see the separation of the sand and the silt and the clay. And so what we see here, of course, is the sand is at the bottom. We've got silt in the middle, as that's the medium-sized particle size, and then the clay is still partly in solution, it looks like in this case. And so again, that could take up to 7 days, but it is of interest to see. If you think about it, most likely it's not something that's hard to do, it's just hard to think to do. And so if you were to do that to garden soil, it'll help you probably better figure out what your soil texture is. And of course, that also shows up on your soil test, which we'll talk about later on in the slides. There is a color chart, and so soil scientists use this. This is something I also use whenever we're doing the soil judging competitions, and that can help tell you what the soil is made out of, what the parent material is. It's valuable to consider whenever paired with other features, but just know there's a tremendous amount of color variation between soils. I have seen soils that have been almost white, and that's not just parent material, limestone rock, but that's actually topsoil that looks that color. Depending on what the nutrient makeup is, what the parent material is, what is grown there, where it's from. Many different things contribute to this. If it has oxygen or not, if it's underwater, a lot of times soil tends to be gray in color because of chemical reactions. So just know there's a wide variety of colors for soil, most of which is brown, of course, but there can be soil that's gray, white, yellow, and any variation in between. And so there are books that soil scientists use to try to dictate what those colors, and then just like your box of crowns, each one of those colors has a different name. Okay, we talked a little bit about sand, silt, and clay. If you were to look at this on a microscopic level, of course you can see sand. We know what happens on the beach whenever water hits the beach. When it hits the sand, it disappears very quickly, so we know that there's large pore spaces there, so it's hard to compact sand. As water hits that, it very quickly, as you can see here, can run through it. That's also the case with nutrients. And so if we were to look at surface areas, if we were to calculate the surface area of a garden full of sand compared to the surface areas of a garden full of clay, there's a tremendous amount of surface area with each one of these particles. And so surface area is important because these things almost act as little tiny magnets. Each one of those particles has a magnetic charge. It's important to not only hold water that way, but also all of our nutrients that we apply also can have a positive or negative charge. And so depending on the amount of pore space we have, that dictates our holding capacity for nutrients as well as our holding capacity for water. A lot of people ask if they can improve their soil by bringing in a truckload of sand. And of course that is possible. On a larger scale, that's not likely to be very practical. Most likely you're having to deal with what you were given. You can amend it through organic matter, but it's less likely to be able to amend your soil texture through the addition of sand, or in the case of having a sandy garden soil, through the addition of clay. It's not normally advised. But basically, the less total pore volume you have equals less porosity. Greater total pore volume is greater porosity. Okay, so this is the difference between sand and clay. Silt being right there in the middle. Okay, as I mentioned before, you can actively change your soil texture, not as easily through the addition of sand or clay, but through the addition of organic matter. And so on a smaller scale, all of these things can be adjusted much easier. But on a larger scale, the addition of organic matter is most likely going to be your best way, and that can be through the use of cover crops or adding compost or manures, things like that. In Arkansas, generally, we have between 0.5 and 2% organic matter, and so that could increase in the Delta, depending on the land use there, probably decrease in Northwest Arkansas. If we were to go somewhere like the Midwest, they might have up to 4% organic matter. Just know, even though it's dark and rich and beautiful, the total percentage compared to the parent material is most likely well below 10%, even with the addition of organic matter. Now, I have seen raised beds that a lot of master gardeners like to use, and projects are used with, which are raised beds, which they use 100% organic matter, and so that's certainly possible. But what we're talking about here is general garden soil, and so in Arkansas, we're looking at between 0.5 and 2% organic matter. Those can, of course, change. I mentioned what the land use is, depending on how long the soil has been used for agriculture, no-till practices, how much it's tilled. Those things can affect the organic matter. But again, we're talking about, there's the word horizon. We're dealing with the A horizon here, and so that's where the activity in the soil is taking place. 1 teaspoon of soil, and so we know, of course, compost is incredibly active. That's bacteria and fungus that's breaking down that organic matter. Earthworms, all those things are living in the soil, and so the more biologically active the soil, the faster some of these cycles are happening. Nutrients are changing forms into plant and available forms. Water is being held. Organic matter does tremendous amounts for our soil, so it can help make it the tilth better. So as we try to work soil that is heavy in clay, with the addition of organic matter, we can make the tilling and the disking of that soil work way better. We can help either hold water or help allow water to drain out with the organic matter. So just know, in general, the addition of organic matter is good. I know that Dr. McWhirter talked a little bit about having too much organic matter and how that can actually tie up nutrients and different things. But in general, organic matter is good, and having live, healthy soils is really good, as most of us know. We don't tend to want a sterile environment unless we have run into a lot of problems and we're having to fix that. But I know that a lot of people have seen the figures on what a tablespoon of salt water, how much life is in that. Same thing with soil. Soil is a tremendous probiotic, I guess, in a lot of ways. So we have something like 100 million to 100 or 1 billion bacteria. A lot of these numbers, as they get into the millions and billions, don't mean a whole lot to me. Just know that soil is incredibly important. It's incredibly alive. It's important for all the cycling of these nutrients and breaking down of parent material. But there's bacteria, fungi, protozoa, nematodes, which can be good or bad, arthropods, earthworms, basically more organisms in a teaspoon of soil than humans on Earth. And so as we look at these just mind-boggling numbers, just know that a teaspoon can be incredibly important and alive, and it's not just one thing. Say if we've run into some soil problems before, it's not just that one thing that's living in the soil. A lot of times there's competing things. More likely, the more active and alive our soil is, the better and more resistant it can be and healthier for our plants. Okay, one thing that those microorganisms do is, if we are to apply fertilizers, a lot of times those aren't in directly plant available forms. And so if we just have nitrogen, we just have phosphorus, if we just have potassium, a lot of these materials are mined materials, or they're not in a plant available form. So what we need is for microorganisms to actually take those parent nutrients and break them down and put them into a plant available form. We'll talk a little bit about what fertilizers provide later on in this talk, but we'll take nitrogen into a nitrogen form, phosphorus, which would just be P, if we were talking about chemistry, and break it down into P2O5, which is what the plant available form is of phosphorus, K2O in the form of potassium. But just know that in order for nutrients to become available, they have to be broken down and changed by microorganisms. And so a sterile environment will certainly not do that near as well or at all, for the nutrients won't be available to the plants. Okay, so we talked about what microorganisms can do to the soil, and this is, of course, what humans can do to the soil. So as we farm, as we till the ground, this is less and less. I mean, as we know more and more, this happens less and less, but there are some unintended consequences. We think we're doing a really good job by growing a garden, but if not properly protected, then we can lead to situations like this. So if you till your ground, if it's on a slope, certainly we get a big rain, then you're going to run into problems like this. Of course, this is erosion, these big gullies that are forming not only in the hillside, but through the entire field. And so as we till, we're exposing that soil to the elements. So in this case, water, but wind. In the case of the Dust Bowl, we saw a lot of soil moving from where it was needed, basically becoming dirt or dust, and moving to where it wasn't needed, and that caused big problems throughout the Midwest. And just so that you know, tillage is an important practice in gardening and farming, but can have negative impact, and it's certainly something that we need to be aware of as we do change the landscape. As we do till, one thing that happens, and it is something that I see quite a bit, as we have our walking tractors or our walking rototillers or Troy-Bilt tillers. We put those through the garden, and we've done that year after year, and we use that not only to break up the ground in the spring to get the soil alive and woken up, but we also use it for our weed control. So if you plant everything on 30-inch centers and you run the walking tractor through there every 10 days or something to take care of your weeds, which does a really good job, what you can over time do is create a plow pan, and this might be done over time, or this might be done just over a single pass, but as you do it year after year, it can become worse and worse. There are ways to remedy it, but just know what's happening below the soil surface. So if that walking tiller, or if it's a tiller on the back of the tractor, or if it's a plow of any kind, disc, what it can be doing is it's going at the same depth year after year, or pass after pass, and what it can actually create is what's called a plow pan. And so what this yellow line indicates is a seed. Seed is germinating, put down roots, and then it actually hits that plow pan and then heads horizontally. Okay, and so depending on what the plant is, of course, we know things are hardier than others, but in general, what this has created is that tilled layer. So say this would be a rototiller on top that made that really fine powdered soil. You know, this might be also a rototiller that went a few passes a little bit deeper. This might be your disc that went even deeper, but all of those created a plow pan at that level that it was run. And so it is important to be aware of. In a garden situation, it might be harder to clear up than on a larger scale, where you can pull a chisel plow or something like that through with your tractor, but there are ways to do that on a garden. I've seen a lot of people just use like a digging fork and put that down there and pull it back and try to break up the plow pan that way. Of course, that's pretty labor intensive, but just know it can be affecting the movement of water as it goes through here. It hits this layer and it might settle, so you might actually have roots that are sitting in water. Even though you might have a good soil texture, you've created a plow pan in this situation that is keeping both roots, but water and nutrients from being able to penetrate. So over time, and one of the reasons why no-till agriculture is becoming so popular, both on a large and on a small scale, is because over time, we've talked about how active and alive the soil is. We have earthworms that might be coming up here and making a channel, eating along the way and leaving a tunnel. That tunnel is going to, over time, be a great spot for water to infiltrate and for nutrients to infiltrate, for roots to be able to hit and infiltrate. And so you can see here in the same situation with a seed planted at the same depth, those roots are going to be able to reach that tunnel or that channel, and then going down way deeper where they can access maybe water in the case of drought that's being stored deeper in the soil profile, but also nutrients, and just create a more robust vigorous root system in general. In this case, you might run into a situation with lodging if it was corn or beans, where after a big rain or a big storm, that plant could actually fall over because the roots didn't go deeper than 6 inches or something like that with the plow pan. But in this case, we have a tremendous amount of water that's able to infiltrate the soil, so we don't have near as much runoff. If the soil is being covered, then we have less of an issue with erosion in the form of wind and rain, and just a much more active soil. Over time, these soil form structures in the form of PEDs is what they're called. And so there's just a whole lot more tilth in the soil. It might take a while for this to get started from this situation to this, but just know over time, the soil can become more active the less we till. Generally, the more active the soil remains, as we're not sort of interrupting these channels and breaking up those pores. Okay, this is a real life picture of what a plow pan would look like. And so in this case, we have 2 compacted layers. Of course, there's the beans growing there, there's their roots. You can see where a lot of roots hit this very first plow pan, which is in case something formed by a disc. And then you have your second, which would be probably more of your moldboard plow. So the plow would have gone deeper, the disc would have gone less deep. This might be 18 inches deep here that the plow pan made. The disc might have gone only 12 inches or 8 inches deep. But in this case, it did create 2 separate plow pans. It's something that might be inevitable, but it's something to be aware of. A lot of farmers every year, every 3 years might go in here with something like a chisel plow, something that's a deep single shank, and try to rip these plow pans. But you will also see, partly for this reason, a lot of large-scale agriculture has moved towards no-till agriculture because there's less risk of creating these pans. There's less times that the tractor has to go over the soil. There's less possibility for erosion. And so we're able to be better stewards of the land as we know better what's happening below the soil surface. Okay, another way that we can change what happens with the ground and remain active is the use of cover crops. Amanda also talked a little bit about that, but in this case we have crimson clover. It's not only beautiful and provides flowers for beneficials and for honeybees, but it's also keeping that soil nice and active, okay? And so this case, it's a legume, but it can be any number of things or any number of mixtures of crops, cereal or legumes. In this case, the soil is covered, and so we do have a slight slope. And so if this was a tomato farmer, most likely this person was going in spring and working the ground, planting. They might be done with their crop by August, and so they can turn around in September, plant something like this crimson clover or red clover, keep the soil covered so there's less potential for the soil to wash away. That also keep the soil cycling. They're able to continue to feed those microorganisms so there's not the great fluctuations of life and death, and they're also just able to keep organic matter cycling. So these plants are able to take up nutrients that otherwise might be lost through the soil profile. These plants are growing and then holding those nutrients until they're then killed through mowing or through winter or through plowing, tilled into the ground, and then those nutrients that were held by the crimson clover would then be available to the tomatoes or whatever's growing next. We talked about how that cover crop in particular, the crimson clover, is a legume. A legume is beans, alfalfa, peas, clover. There are trees that are also legumes, but what legumes are able to do is they can take the nitrogen that is in the air, and so 80%, 78, something like that, percent of our atmosphere is in the form of nitrogen, but that is N2, and so that is a plant unavailable form of nitrogen, but we have a tremendous amount of nitrogen in the atmosphere on Earth that's not available readily to plants. But what legumes can actually do is they can take the nitrogen from the air, which is 80% of our atmosphere, and convert that through these nodulars on their roots, which is actually a bacteria. So it's a symbiotic relationship between a plant and a bacteria. They're able to take that nitrogen from the air and in turn turn it into a plant available form of nitrogen that is readily available to the plant. In this case, it's readily available to the white clover, but after that white clover is terminated, tilled into the ground, or terminated and let lay on the ground and then decomposes naturally in the soil, it's available to the next generation of plants. And so legumes do a tremendous amount for us. It's one of the probably miracles of life that allows things to be sustained, but they can take the nitrogen from the air, put them into the soil. And so I think the relationship is basically the plant provides carbohydrates for these bacteria to build a house out of, and in exchange, the bacteria give nitrogen to the plant. And so it's a healthy relationship between the two. If your soil is not active and alive, then you might need to, as you seed white clover, crimson clover, any number of legumes, actually put an inoculant out with that seed. And so you've probably seen in the past where if you plant your green beans, they'll try to sell you an inoculant that goes with that. Normally it's very inexpensive. It's a black charcoal looking powder. You'll mix that with the seeds as you plant it. If you're planting beans every year in the same spot, it's probably not important because those bacteria are living there. But if you're tilling up your ground a whole lot, if you're growing a new type of legume for the first time, then it's not a bad idea for the cost to go ahead and inoculate those seeds. Okay, also Dr. McWhirter spoke a little bit about crop rotation. And so as we actively use the soil for our benefit, that soil changes over time depending on what we're growing. So we talked about if we're growing a legume, that soil might be inoculated then with the bacteria that turn nitrogen into plant available forms, but also depending on what we're growing next. In this case, they've got nightshades, which are your tomatoes, your potatoes, your eggplant. We know that they suffer from some soil diseases. And so if we were to grow nightshades year after year in the same spot, if a plant that we bought came in infected, or over time that infection builds up and becomes a problem in the soil where it's affecting our plants, then we certainly want to break these cycles as much as possible. So not planting nightshades year after year, taking at least 3 years break in between what we plant there. Nightshades do tend to be the most important thing to rotate, but certainly different root crops. I've seen beet diseases that build up over time. And so as much as we can keep the soil active, it's also important to keep what we're growing there in a rotation, especially in a garden type situation. It is harder as we just have one raised bed or one small garden to rotate these, but the best we can do that is going to be the way that we can best break up the cycles. And so as much as we can keep the soil active, but also growing different types of crops, which grows different types of bacteria in the soil, the better. Okay, another way that humans can change the soil, in this case for the betterment, is maybe the use of raised beds. Again, it's something I see all the time. A lot of home gardeners have started to use more and more raised beds. I think part of that is as we get older, it's more important, but also, I mean, it can aesthetically look great and incredible. It has a lot of benefits in that it's potentially easier to keep weeds away. They warm up in the spring. So of course we know that dark colors tend to warm quicker than light colors. If the soil is up off of the ground, then it tends to warm up earlier in the spring than a flat ground would. It's very tidy, of course, as we can see here. There are some cons. I mean, you do have to build them. It's harder to control the weeds if you get something like Bermuda grass coming in without the use of herbicides. I mean, there's a lot of work if you decide to move it or something like that. So there are some cons there, but just know some of the benefits of changing the soil in the form of a raised bed is the use of a raised bed, and it can warm it up. It can make it way easier. A lot of cases, you're not going to step on that bed, and so compaction is certainly decreased. You're probably not going to till it near as much just because it's harder to get equipment in there. You see it a lot on commercial scale farms as well. So of course they are probably not going to be able to, on the acres and acre size scale, to be able to go in and build permanent wooden raised beds or bricks or blocks. But you do see a lot of commercial growers moving towards raising the soil because it does warm up quicker in the spring. They can also put out the black plastic tarp. In this case, are using the embossed mulch, they can put that out with a tractor and then plant directly into it. It is disposable, but it does keep produce in the near term a lot cleaner, and it provides season extension. Actually, you can put white plastic down that helps you be able to plant vegetables in the summer months a lot easier when it otherwise would be too hot. And this can be certainly cost effective at a larger scale as well, for weed control and for a lot of other reasons. And so there are ways that we as farmers and stewards of the land do change and adapt the soil to fulfill our needs. And so if we had a heavy soil, it's important to have a raised bed and that it can drain. A lot of the water would then go into the pathways. And so it can be a way to adapt the soil that might be less than ideal to be in a better situation for growing and selling produce. I'll move on to soil testing. It's something that many of us do. It's what the Extension Service is known for a lot of times. It's where you take your soil samples to. The soil sample is free in Arkansas, and so it's a part of the tax on fertilizer that's purchased goes back into the soil testing program. And so it's a great service that the state of Arkansas provides for its citizens, and that's a free soil test. It's important to do it as a baseline. So if you just move to a garden or move to a yard, it's important to get a baseline if you don't already have that information. The basic soil test is free. If you do want to get an organic matter test along with your soil test, you do have to pay a little bit extra, but I think it's $5 or less. And it doesn't readily test for nitrogen, and the reason for that is nitrogen tends to, as a chemical, and the chemistry of nitrogen, it tends to be very volatile. So as you take your soil sample, you put it in a bucket, you put the bucket in the back of your truck and let it dry out. That nitrogen has changed forms probably many times at that point, and it's going to be very difficult to get an accurate reading by the time it gets shipped to Mariana and then back to us to tell you exactly what nitrogen is in there. So a lot of times you'll see a generic recommendation for nitrogen, and that's the reason for that. What you'll need when you do your soil sampling, we have probes at the Extension office. You can certainly come there, and we lend those out all the time. That can aid in taking a proper sample. You could do it with a fork if that's all you had, but certainly a spade, something like that. Go out into your garden. It's important to take a sample that's 4 to 6 inches deep. This talks about needing a soil sampler, not always necessary, but some way of getting access to the soil. A clean bucket. It's important not to use an old pickle bucket, something like that. Those might be residual nutrients on the surface of that bucket. And so if you're putting your soil in that bucket and mixing it around, you're going to be taking whatever's on the inside of that bucket with you whenever you put the soil into the box. And that's going to probably show up in tremendous numbers whenever you get it back from the soil lab. And so it's probably something I see a lot of with iron numbers being extremely high. Someone takes a rusty old shovel or something like that and digs up their soil with that. Well, of course, that rust then comes into the soil and can show up on the soil test. And so just know we want to use clean utensils, clean hands, clean sandwich bags, or whatever it is that's touching the soil, just because it can have a tremendous effect on those results. And so you want to get as accurate of a readout as possible. And then it says here, having a plan is extremely important. And so you'll be asked on that box to write whatever it is. If it came from your yard, you'll probably put backyard, front yard, something like that. It doesn't matter what you put, just so that you know what it is. And so whatever is probably the most self-explanatory is the best, just because if you didn't keep good records, 10 years from now, you can look at that and know that it's front yard or field 1 or east field or back 40 or whatever it might be. Okay, it's important as best as possible, if you want to have an accurate reading, is to take a core sample from multiple spots in your yard. Okay, and so this map says your front yard here. It might be different than your backyard. You know, once upon a time, whenever they built the house, they might have taken the dozer and pushed up all the soil to make the landing for the house, something like that. So just know if you have natural changes, this one has trees and shrubs, it has the vegetable garden. If you have natural changes in your soil that you're trying to get sampled, just break those up into different samples. It's also important to get different readouts or stick that soil probe in different places throughout the soil. If you could think about it, we're taking ultimately a pint of soil, we're mailing that off to Mariana. They might be just taking an ounce of that soil for each different test. If it's just from one spot in your garden, then it's likely not to be a complete picture of your garden as a whole. And so as much as possible, if you can take different profiles of the soil going down 4 to 6 inches in the case of a garden, putting that in your bucket, mixing it up as best as you possibly can, and then putting that into the box, it's going to be a better readout than if it was just a single, spade or shovel full of soil from one place. Of course, if there's a bare spot where nothing's ever grown, that's not a good spot to take a soil sample. Take it from the best sort of general readout of what the soil, looking at it from, standing back a little bit. Okay, a few tips. We do ask in the office that we have dry sample, and so if you bring in a muddy mess, we're going to then have to dry it. So it's best if you can let it dry out a little bit beforehand. I talked about 4 to 6 inches. Could go deeper if it's a tree that's going to be going in, but general garden, we're talking about 4 to 6 inches deep. The cores should be random, and then as much as possible, if you can remove rocks, plant residue, it is important that we have a complete pint, which is what that box is, of soil, and that doesn't have a whole lot of other things that are going to have to be dumped out. If half of it's a rock, then we've not got a full pint of soil. Okay, so we do have boxes available. People are welcome to come and get a couple boxes for future use. You can bring things to the office in a clean bucket or Tupperware or Ziploc bag. Those things are very common. That's perfectly fine as long as we do have a pint of soil. We will put on that box a few basic labeling things. I think this is pretty self-explanatory. We will ask what is growing, what you plan to grow, and it's also important to know if the soil has been limed in the last 4 years. So that lime is basically rock that's been ground up and has been applied to the soil. And that might have been applied to the soil surface, so that takes time to work its way down the soil profile. It also takes time for the bacteria to break that lime up into a plant available form. And so it's important that we know if it's had lime applied. If you applied lime last year, then for the next 4 years, that lime is going to become more and more available. And so it is going to affect that readout and the recommendations that we'll make. But we'll also need to know what you're planning on growing, so we can make the nutrient recommendations based on that. If you're growing blueberries, then that's certainly a different pH than blackberries, and so we want to know that. We want to be able to make the proper recommendation depending on what you want to grow. Okay, this is your basic soil test readout that you will get, and so you'll see if you get it in the mail, looks like it's got a note from your county agent. If I don't know exactly what your plan is, I might just put my phone number on there and ask you to call me, and we can talk through that if you've got any questions. But in general, I'll try to write a paragraph or something on there, just kind of explaining a few things. One thing I'll do is I'll highlight the field ID, which in this case, it's been blacked out. But just to make you aware, because it's not always easy to look at this and know where everything is, it'll have your name and address up here. It'll have your client ID, which is your phone number. It'll have some of the information that you provided. Is lime applied in the last 4 years? It's been leveled, irrigation practices, that sort of thing, just so that we can have a more full picture of what you're planning on doing with the soil and where the soil is coming from. One important thing to look at is your soil pH. We'll talk just in a few minutes about that being the master variable. Depending on if it's below or above 7, that makes it acidic or alkaline, and so it's important to know that, because that's most likely going to be the number one thing to adjust. If that's well off of 6 to 7 is normally what crops want, but we'll want to address that as soon as possible. That's a lot of times the most important thing to address, because it does take time to adjust. And so if we're putting down lime in the case of wanting to raise the soil pH, or if we're putting down sulfur in the case of lowering the pH, we want to do that as quickly as possible so those microorganisms can sort of break down and change that soil and get that ball rolling. You'll also see some important figures. You can certainly do a deep dive into all of these numbers and read forever about what they all mean and how to best interpret them. Most people care about the pH and then their nutrient levels, and so I won't go into great detail. I will mention a little bit about the soil ECEC. That's your exchangeable cation exchange capacity, And so basically the higher that number is, it's the equivalent of the more pore space. And so cation exchange capacity, cations are normally your nutrients with a positive charge to them. Basically the more pore space we talked about earlier, the greater holding capacity of the soil. You'll see a lot of times if this was a clay loam, it would have a higher EC than if it was a sandy loam, would have a lower soil EC. So not incredibly important to look at, but it is interesting for me. It's interesting for some people to look at if they're adding organic matter. That can also change the amount of surface area for nutrients, and so that will also increase your CEC. And so mostly this just is dictated by your soil texture. If I wanted to do an organic matter test, that would be a loss on ignition, and so that would be listed here. Again, that's something you have to pay a little extra for. Of the CEC, this is the percentage of what those sort of surface area or what that particle is being covered by. In this case, basically 53% of that available pore space is being covered by calcium. Again, it's something you can take a deep dive into, but it's probably not appropriate in this talk. We will say over here, though, if you've got phosphorus levels, medium, optimum, high, very high, those will be listed here. And so recommendations will be made down here based on your phosphorus, potassium levels. In the case of garden, a lot of times they'll list out your zinc levels as well. And so if you've got any questions, of course, your county agent can better interpret this for you and is happy to do so. So bring those to him or her. Don't guess soil test. Again, a lot of these things were handled by Dr. McWhirter earlier, so I won't go back over them again. We do have essential elements for plants. Your micronutrients, your primary micronutrients are generally your N, P, and K. Those are also listed on your fertilizer bags. Macronutrients are your nitrogen, phosphorus, potassium. Your secondary macronutrients are sulfur, calcium, and magnesium. And then we have your micronutrients. And so again, these are all listed on your soil test. They have been tested for. It doesn't make a recommendation based on these generally. Something like zinc being low, extremely low in a garden soil, the recommendation is only like a pound per 1,000 square feet or something like that. So these are incredibly low compared to nitrogen, which might be 5 pounds per 1,000 square feet or 100 pounds per acre or something like that. These are micronutrients. They are important for the plant, but needed in far less quantities than your macronutrients. We talked a little bit about the pH being the master variable. Okay, so right at 7 is considered neutral. Anything below that is acid. Anything above that is alkaline. There are ways that you can adjust this, but commonly our pH range in Arkansas is between 4 and 7. In most cases, your garden soil is going to want to be around 6 to 7. And we'll do that, or we'll get to that range with the addition of lime. And so it's not uncommon for pastures, for your garden, for farms to apply lime every 3 to 4 years, just because naturally our soils want to tend to be a little bit lower than where we optimally want them between 6 and 7. Okay, there are cases like with blueberries where we want the soil to be between 4 and 5. And so we'll actually have to add sulfur in that case to bring it down from, say, 5 to 4 in order to bring the soil pH level down. The reason that this is important is because just depending on where you're at as far as pH goes, different nutrients will be available. And so the lower we go, you can see a lot of these nutrients, especially our macronutrients, N, P, and K, become less and less available. Bacteria actually cannot thrive in a situation below 5.5. And so this is the reason why most of your garden soils and most plants in general like it in this green space here between, say, 5.5 to 7 or between 6 and 7, something like that, because most of our nutrients are available at that point. Okay, again, we talked about if it's too low or too high. There are ways that you can remedy that. Here is a bag of fertilizer. We talked earlier about N, P, and K. Generally, garden fertilizers have that listed right there on the front, N, P, K, nitrogen, phosphorus, potassium. 1608 is this turf fertilizer. All fertilizer bags will have an expiration date. They'll have the pounds of N, P, and K. They'll have a product number. This is actually the plant available pounds per 100. So there are 16 pounds of plant available nitrogen per 100 pounds of this product. It does become confusing because most bags are just a 50-pound weight. And so in this case, there's only 8 pounds of nitrogen per bag because it's calculated per 100-pound bag. And so that's something to watch for. But generally, garden soils don't need a whole lot of nutrients. Generally, they are also very good on phosphorus. So a lot of times that recommendation will come back on the soil test of a ratio similar to this, 16:0:8. So it has 0 phosphorus, high nitrogen, medium in potassium, and that might be a pretty common application. And you might only need in a situation like a garden per 1,000 square feet, maybe a couple pounds of this per year. So generally, I don't see a lot of nutrient needs show up on the soil test needed in the garden. We have complete and incomplete fertilizers. If it has all 3 nutrients, then it's considered a complete fertilizer. It will a lot of times mention what micronutrients are available in the bag, but it's not listed there in those big 3 numbers. If it's an incomplete fertilizer, that might be something like potassium chloride, which is a 0,060, potassium sulfate, 0,050, something like that. So there are complete fertilizers and there are incomplete fertilizers. A lot of times a garden, only thing that's needed is nitrogen. And so that might be accomplished through the addition of fish emulsion or something early on in the spring, or feather meal if you want to use organic nitrogen, blood meal. That doesn't have all the complete nutrients. It just has the nutrient that probably you need to apply. And so you can sort of make recommendations just depending on what fertilizers need and what the soil needs. Poultry litter would be considered complete fertilizer in that it has N, P, and K in it. There's a note here, why would poultry litter be a problem in Northwest Arkansas? And that's because generally poultry litter is very high in phosphorus, but is not generally needed in the same quantities by the plant as nitrogen and potassium. And so over the years, we have a lot of chicken farms. We've applied chicken litter year after year. The nitrogen and the potassium are being used by the plants, but the phosphorus is building up to the point where plants aren't using it, and it can run off or it can leach through the soil and get in the rivers. And so there is an issue with phosphorus generally because plants don't need it in the same quantities as they need the other 2 macronutrients. Commercial fertilizers, common ones that you'll see listed on the soil test are urea, which is 4600, triple superphosphate, potassium. Again, a lot of folks want to use organic fertilizers, and that's great. It's sometimes harder to know exactly what the numbers are on organic fertilizers than on the commercially available ones. But just know these are some common ones that you'll see listed. Sometimes they're easier to get in 50-pound bags and at a bulk level than it is in a 5-pound or a 1-pound bag. So on a small scale, 1,000 square foot garden, you might have to just use whatever is off the shelf and try to match your percentages or your ratios as best as possible. Other fertilizers include compost, fish emulsion, animal manures. Miracle-Gro is a slow-release, plastic-coated fertilizer. Grass clippings can be a great form of fertility and organic matter. We talked about legumes earlier being a great form of both fertility and fertilizer in the garden. But there are many forms of fertilizers. Always ask your county agent if you are questioning what to use. I see a lot of people will use something like mushroom compost is what they call it in our area. A lot of times that's not referred to as a fertilizer. That is more of a soil amendment. Okay, I have it listed here. Peat moss, perlite, biochar. Those can have some fertilizer value to them, but are generally used to change the composition of the soil or the tilth of the soil or the water holding capacity of the soil. And so we talked about if you had a clay soil, adding mushroom compost might allow that soil to better suit garden plants. Peat moss could do the same by holding water. Peat moss is also good about lowering the soil pH. And so these might have good fertilizer properties, but are generally used to amend the soil or to change the soil texture in some way. How are we doing in time? We about done? Okay. We do have nutrient deficiencies. Most macronutrient deficiencies are seen on older leaves. So nutrients can actually be portable throughout the plant. So some nutrients are mobile within the plant and some are immobile within the plant. And so if you're looking at a plant and you're curious what is wrong with it, it just looks wrong or it's yellow, it's important to note whether that symptom is showing up on the old parts of the plant or on the new parts of the plant. That way we can know if it's a mobile nutrient. Mobile being new parts of the plant would take it from the old parts of the plant. And so generally nitrogen deficiencies would show up on the old leaves first before they would show up on new ones, because the new growth is able to take the nutrient from the old growth. Okay, these are some symptoms or some signs of a nitrogen deficiency. Generally, we know them as being yellow. Again, nitrogen is a mobile nutrient within the plant, so nitrogen is able to go from old leaves to new leaves, and so the yellowing will appear first on old parts of the plant. Phosphorus deficiencies, to me, a lot of times show up as sort of burning. It's hard to tell the difference between phosphorus deficiencies generally show up as purple of the plant, and so the plant starts to turn reddish purplish. This happens particularly in the spring before the soil is nice and alive and the micronutrients are active. They're having a hard time providing the phosphorus that the plant needs, so the plant's growing very quickly, but the soil is still very cold. Phosphorus symptoms or phosphorus deficient symptoms will show up a lot of times in the spring. It doesn't mean that the soil doesn't have phosphorus in it. It just means that the soil is unable to provide phosphorus for the plants. Potassium deficiencies, I mentioned earlier, sometimes show up as drought symptoms as well. So that's why it's important to know if they're just on the old parts of the plant or if it's on the new parts of the plant. A lot of times potassium is associated with fruit. And so if you have poor fruit, sometimes that can be a symptom of low potassium. And so there are generally pictures here you can say. I mentioned before that the two biggest nutrients probably that plants use in most cases are nitrogen and potassium. So those are the biggest deficiencies that we see. There are many micronutrient deficiencies. We've all probably seen the blossom end rot in the case of tomatoes. And so we see the black at the bottom of the tomato there. That is a calcium deficiency. And so that is a secondary macronutrient. A lot of times that's cured by a liquid calcium drench, or you can spray the leaves with liquid calcium in some cases to clean that up. But very common in tomatoes. Tomatoes tend to use a lot of calcium, and that's one symptom that shows up. But depending on what it is, a lot of times the micronutrients will show up as a symptom, and it's hard to tell between a problem with micronutrients or a disease. So it's important to get samples. We can take those into the lab and we can figure those out a lot of times for you. We do have nutrient surplus areas, and so it is important to know if you are applying nutrients, especially to over 3.5 acres, you do actually have to have a nutrient management plan. And so just be aware of those. There are parts of the state where, again, the phosphorus is at a level where we don't want to apply more than we need, and so it's important to be aware of that. In summary, I will say then, soil is incredibly important to us. It's probably, besides water, the most important thing that we have at our disposal, so it's important to be good stewards of the land and our soils. The addition of organic matter can a lot of times alleviate problems with texture or with nutrients. The extension agent is always there to help if you've got any questions, and just follow the best management practices as you can.